Good morning. Welcome to Maths Today. Today is Tuesday the 19th of January and your skill today is to compare and order fractions greater than 1. Okay, now we were doing that yesterday with proper fractions, okay, with the numerator smaller than the denominator. So today we're using mixed numbers and improper fractions. First things first, so if you could please complete your arithmetic challenge, which is here. Okay, make sure you have underlined your skill and date. You've got your 3 times tables. You have got silver challenge, which is completing the sequence. Okay, so look carefully at what the numbers are increasing or decreasing by. And then you've got your gold challenge, which is times them by 10, 100 and 1,000. Okay. Pause the video, take your time and come back when you're ready for the answers. Good luck! Okay, so here are your answers. Okay, so go through those, tick the ones that you got right as always, and make sure you can identify where you went wrong if you did. Hopefully you didn't. Okay, so really push yourself to try and complete all of those, please. Okay, quick recap then. So choose the fraction which will give you the most chocolate. Okay, so we have got a chocolate bar here and there are 6 pieces across. Okay, so we have got 4 down. So 6 across and 4 down, you've got 24 pieces of chocolate. Which fraction would give you the most? 3/6 or 3/4? So if you divide the chocolate bar into 6, will you get more? Or if you divide it into 4, will you get more? Remembering when we spoke yesterday about the numerator being the same, okay, which means that if you split it into 4, you'll get more chocolate. Okay, have a go at this one. 5/6 or 10/12. Which one would you choose to give you the most chocolate? Have a look at those fractions. Are they equivalent? Okay, so you could have both. Yeah, it's the same amount. Because 6 times 2 is 12, 5 times 2 is 10. Okay, how about this one? So we've got 2/6 or 3/6. Okay, so they're both divided into 6. Would you prefer to have 3/6 or 2/6? Hopefully 3/6 you would have. It's the same as 1/2. Brilliant. Okay, which of these fractions are greater than 1? Okay, have a look at the fractions, pause the video, okay, and come back when you're ready for the answers. If you're in the bubble, you can have a chat about why they're greater than 1. Okay, so the ones that are greater than 1 then. So, greater than 1 is if they've got a larger numerator and a smaller denominator, okay? So we've got 12/6, because we can divide 12 by 6, okay, to get 2. Then we've got 11/10, because 10 goes into 11 one time, with 1 left over. Again, we've got 13/12, because 12 goes into 13 once with 1 left over. And finally we've got 20/19. Okay, so you can get 19 into 20 one time. Okay, now this one here is 5/5, so it is 1, but it's not greater than 1. Okay, good job. So let's learn then. So as I mentioned, yesterday we were comparing and ordering fractions. Today we're going to be doing the same, but with improper fractions and mixed numbers. So let's compare these two. So we've got 5/3 and 7/6. Remember, you can think of that as a divide sign. So how can we represent these fractions on a bar model? Okay, now you've done practicing of this yesterday, so you should all be okay with this now because we've done quite a bit of the bar model work with the fractions. Okay, so how many equal pieces should our bar models be divided into? So if we think of the first fraction, 5/3 then, what should it be divided into? So we're looking at our denominator to see how many equal parts, and it is 3. Okay, we've got 5 out of the 3 parts, so we can colour 5. So 3 shows 1 whole, and then we've got 2 extra, because if we divide 5 by 3, we get 1 whole and 2 left over. Okay, so it's the same as 1 2/3. Or it's the same if we make it an equivalent fraction to the one at the bottom. Okay, we've got 3 and then we go into 6. So we're timesing that by 2. We're going to times 5 by 2. So we could have 10/6, which would of course be bigger than 7/6. So now we've got them drawn out, we could compare them. And we can see that 5/3, so 5/3, is greater than 7/6. So we've compared them. Okay, so we can draw the bar models to help us, remembering our equal parts. So our whole bar model is the same size for all of them, they're just divided into different amounts. Let's try another one. Compare 4/3, so 4/3 and 8/6. Okay, can you predict which fraction will be larger? Okay, so looking at those fractions, looking at the numbers, can you make them equivalent? Can you work out which fraction will be larger? Okay, so here are our 4/3. We've divided our bar model into 3 equal parts because that's our denominator. Okay, and we have shaded 4 of them. And then we've got 6 equal parts for our second fraction. Okay, because our denominator is 6. We've shaded 8. What do you notice? Okay, so hopefully you'll notice that 4/3 is equivalent, it's equal to 8/6, okay, because the same amount is shaded. Okay, so again, if we change that to an equivalent fraction, it would be 8/6 if we times both the denominator and numerator by 2. Okay, do this one with me, or if you're in the bubble, then do it all together. So let's try another one. We're going to compare 5/3 and 11/6. Okay, so we've got our denominator, which is 3 for our first bar model. So we need to divide it into 3 equal parts. We're going to shade 5 of those equal parts because that is our fraction that is shaded 5 out of the 3. Now 3 is 1 whole, and then you've got 2 left over. Pause the video, okay, take your time with this, and then obviously start it as you need to. We've then got 11/6, so our bar model is going to be split into how many equal parts? 6 equal parts, and we are shading 11 of them. Okay, so now we can compare which is the greater fraction. It is 11/6 because there is more shaded of this one than there are of that one. Okay, independent practice time. Have a go at comparing these fractions independently. Okay, so you've got 5/2 and 9/4, 5/3 and 10/6, and 9/4 and 17/8. Okay, have a go at doing those. Pause the video now, keep them on the screen, and then come back when you're ready for the answers. Okay. Remembering at all times both shapes must be the exact same size, okay? They're divided into a different amount of pieces depending on the denominator. Okay, so answers then. 5/2 is greater than 9/4. 5/3 is equal to 10/6. Hopefully you noticed that was an equivalent fraction. Okay, so they're equal, completely equal, because 3 times 2 is 6, 5 times 2 is 10. Okay, and then 9/4 is greater than 17/8. Good job. Okay, how could we compare 1 3/4 and 1 3/5? What do we already know about fractions when the numerators are the same? Okay, so if I had a chocolate bar and I split 1 into 4 pieces, 1 into 5 pieces, but I offered you 3 of those pieces. Remember I said yesterday that the smaller the denominator, the bigger the fraction. Okay, so we can see here they've been split into 4 equal pieces and 5 equal pieces. I'm going to give you a whole bit and 3 pieces. So you're going to go for the 1 3/4. The smaller the denominator, the larger the fraction when the numerators are the same. Okay, so we can see that 1 3/4 is greater than 1 3/5. Okay, so let's compare 1 1/3 and 1 2/6. Can you compare this fraction mentally, or these fractions mentally? Okay, look closely at the numbers. Obviously pause the video if you're in the bubble. Okay, go as slow as you like or as fast as you like. Okay, and if you're at home, really take your time to think about these. Hopefully this one is quite obvious, that you've got 1 1/3, 1 2/6. It's the same. If we multiply the denominator by 2 to get 6, we've multiplied 1 by 2, the numerator, to get 2. Okay, so they are of course equal. Okay, so it's very much the same as what you did the first time. Okay, this time I would like you to write the fraction down. So you have got, the first one is divided into 4 equal parts, and that is going to be your denominator. The second fraction has been divided into 8 equal parts. Okay, so pause the video, see if you can work out the fractions, the mixed numbers, okay, and then come back when you're ready for the answers. Okay, so we have got 1 whole and 2 out of the 4 pieces shaded for the first fraction. Then we've got 1 whole and 11 out of the 8 pieces shaded. Okay, have you noticed my mistake? Hopefully you have. That shouldn't be 11 over 8, that should be 3 over 8, because 11 over 8 is our improper fraction, but we've changed it to mixed numbers. Okay, so I've got my 1 whole here, which is represented here, and then 3/8. I could say 11/8, but I can't say the 1 as well. It's either the 1 or the 11. Okay, because when we look at mixed numbers, the numerator has to be the smaller, it has to be a proper fraction again. Okay, so that is larger than 1 3/8 or 11/8. Okay, let's have a look at another one. So we've got, again, pause the video, see if you can work out the answer. Come back when you're ready. Okay, so this time we've got 1 and, it's not 7/5, it should be 2/5. And that is 1 12/8, which is of course not 12/8, it's 4/8. Okay, so you're either using the 1 2/5 or 1 12/8. Mrs. Coleman had so much trouble doing this PowerPoint because every time I tried to do something, it kept saying there was a fault in it, it kept shutting it down automatically without saving it. So I kept thinking I'd gone back and checked it, and obviously I missed this one. So I do apologise. I'm very sorry, but you are so clever that I'm sure you would have already picked up on it. Okay, and we can see that this fraction is larger. Okay, so independent practice time, you're just comparing the fractions again. Okay, this time you have got mixed numbers, and as you can see, these mixed numbers are correct because they are mixed numbers with proper fractions. So at least I've done something correct. Okay, pause the video, try your best. Okay, remember that both shapes, if you're drawing a bar model, must be the exact same size. It's so important Okay, you're just dividing it into different amounts dependent on the denominator. So pause the video, come back when you're ready. Okay, we can see that 1 3/4 is greater than 1 3/8. 1 5/8 is greater than 1 1/2. 2 9/14 is greater than 2 3/7, or 2 3/7 is less than 2 9/14. And 2 6/8 is equal to 2 3/4. Okay, so now we know how to compare fractions. Let's have a go at ordering them. Okay, so you've got your fractions here. Can you predict which order they're going to be in? Okay, have a think about the numbers. If all the numerators are the same, can you predict what order they're going to be in? Okay, so we've got 1 and 1/8, 1 and 1/2. Looking at it, although it's only divided into 2, okay, it's still the same whole size. The bar models are the same size. And 1 and 1/4. So hopefully you would have been able to identify that before the bar models, okay, because you looked at the numerators. And you can see they're all the same, so it just depends on the smaller denominator is the larger fraction. Okay, and have a go at another one. Are they as easy to predict? What would you need to do for these ones? Okay, so these ones, to be able to order them, you can of course draw bar models, or you can change them to equivalent fractions. Okay, so we have got 11/8. We have got 3/2, 7/4. Okay, so we can see that the order of these fractions is going to be, they're in the right order. So we've got 11/8, 3 2s, and then 7/4. Okay, so we can see that this is smaller than this one, and that's small. So 11/8 is smaller than 3/2, and that's smaller than 7/4 or 7/4. Okay, so these ones are a little bit trickier, okay, because the numbers are bigger. Okay, but even so, the boxes are still the same size. Okay, they've just been split into more bar models, okay, to individual bar models, but the numbers are the method is still the same. You can still split the boxes into equal amounts, okay, equal parts. Okay, so let's have a look. So we've got 32/14, 18/7, and 2 wholes and 12/28. Okay, which one's bigger now? Okay, so if we order them, so pause the video, have a chat, see if you can identify which order they go in. Okay, so we have got 32/14 is our smallest fraction, so that's smaller than 2 and 12/28, which is smaller than 18/7. Okay, again, now it's your turn. So order the fractions from smallest to the largest. Okay, you could draw bar models to help you, but if you do, remember they must be equal in size. You are going to get really bored of me saying that, but it's important that you do remember. Okay, so you're just ordering those 3 fractions in each one. So there's 3 questions, you have to order 3. If you finish that really quickly, okay, think of 3 fractions of your own, write them down, and then see if you can order them. Okay, if you're waiting for others and if you're in the bubble. Okay, but have a go at that. Again, if you don't have to draw the bar model if you don't need to, but it will help you to visualize the fractions. Okay, pause the video, come back for your answers. Okay, here are the answers. Okay, these are in order from smallest to largest. So question 1, okay. This one, really, all you had to do is to work out whether 2/3 is bigger or 8/9, because you can see that 3 wholes is going to be smaller than the 5 hole that you've got. Okay, and then again, the second one, okay, it would have been helpful if you worked it out into a mixed number to be able to work out the fractions. And then the bottom one, you could times the numbers at the bottom because they're all multiples of 3. Okay, great job. Your final thought today then. Eva and Alex have 2 identical pizzas. Eva says, I have cut each pizza into 6 equal pieces and I've eaten 8. Alex says, I've cut each pizza into 9 equal pieces and I've eaten 15. Who ate the most pizza? Okay, who ate the most? Pause the video, have a chat. If you're at home, try and work it out, okay? Do your bar models or write the fractions down to help you. Okay, see if you can work out who ate the most pizza. And then come back for the answer. And your answer, of course, is Alex ate the most pizza because 15/9 is greater than 8/6. Hopefully you would have got that, especially if you drew your bar models. And they were the same size. Okay, that's all for me for now. I shall see you this afternoon. Have a lovely morning and I'll see you later.